Um, oh, let me just push OK on the recording. Okay. Yeah, so my name is Laura Dozal. I'm a PhD candidate at the in the College of Information at the University of Arizona. Um, I'm putting that I'm a Jetstream fellow because they provided a lot of the computational resources for this work. And so essentially, I'm just going to go over my dissertation research, where I attempt to identify a narrative from a collection of topical images. So I do this using kind of a Frankenstein version of different frameworks put together based in computational social science. So essentially, I started off by establishing my research question and claim, attempting to become a domain-specific expert or just get more information about the domain that I work in, um, and then go through and build kind of this mixed methodology design where I implement and iterate human in the loop, uh, grounded theory, and a lot of these computational methods to answer my question and go through my analyses. And so this is kind of like where the research design and the conceptual framework come together. So essentially, I, as we all know, we get a lot of more information from social media. Um, and so the here is where I kind of had this idea, well, we're getting a lot of fragmented information. Nothing is streamlined. It's if so the case study I'm working on is a social movement. So if we get an image like a call to action or some type of information about a march, the next image we get or the next post we get on social media could be like a baking video or some type of like, I don't know, something else, right? And so working with some of these social movement practitioners, you hear them kind of say, well, once we put something out there, that's it. And that's kind of like we have no control over the messaging. And so how it's being understood and how it's being used is out of our hands for the most part, right? And so that kind of put this idea in my head to go through and provide this purpose for this research is to kind of maybe get a better understanding of how these online messages, how the narratives of these online messages are being circulated or what it is and what can we get like some type of concrete understanding. Um, so again, set out to identify a rhetorical narrative from a collection of topical images using computational and content analysis. In this case, I'm looking at rhetorical narratives, not so it's not a literary sense of like a narrative with a plot and then the arc and then the whole like defining action and things like that. But it's kind of it's used to argue for some type of situated discourse. And in this case, I'm using uh, an Instagram post, particularly an Instagram image. And so here we're looking at how this image or how an Instagram image within the collection of other Instagram images based on this movement um, can support an idea of a narrative, of a rhetorical narrative, excuse me. And so um, here I'm working with the anti-feminicide movement in Mexico. And this, for multiple reasons. Uh, One of the reasons being is that it's a really it's a decently decentralized movement online where it's not just put in one place like Instagram or Facebook, but it's spread across. And so initially I wanted to just kind of do a full range of the full digital environment for this narrative. But if you know dissertation restrictions and time and all this, I stuck to just Instagram. Potentially it was easier and it provides that visual aspect. Um, and so this movement has it's a good variation of content, colors, like types of information that's provided in with it. Um, And what's great is it all seems to be pointing towards the a similar cause represented by various perspectives. Um, of course, there's always going to be some, op opposing views of a social movement, but for the most part, there was it seemed to be from initially, I guess, it seemed to be like a nice um, way to go about it. So essentially, I started off with um, I guess, a grounded theory review of the literature, where I found that through the years, the first recorded case of feminicide in Mexico was in the early um, 80s. And so since then, it's the narrative of who the victims are and victimizing these uh, and then the victims stems from some type of cultural, social, and humanization aspect. And it starts off with a mix of social, cultural, and then somewhere along the lines, like victims' families come in and start, advocating for their loved ones. And then humanization comes in through a digital aspect where that message gets to be spread across in various ways from various perspectives. And in this case, um, you can look at this kind of, I guess, digital activism in somewhat of a hierarchical lens, where global campaigns went around and spread the message globally and kind of stemmed from other movements that are similar to gender violence, but they also kind of like brought more information to the country. And then within the country, you kind of looked at the national level of larger kind of um, countrywide marches and protests and how that worked. And even there was a group in 2020, I believe, 2019, who went in and took over a couple of federal buildings in the name of anti-feminicide. And then at the local level, uh, a lot of digital tools were being used to build communities and meetups for victim families and kind of do support resources for women across cities. Ah, okay. So, um, just the way that I kind of tried to become or tried to better be put into the domain in this case. I'm born and raised in a border town on Texas and Chihuahua is a state in Mexico. And so I worked for the past maybe 3 years plus. I've been working with this group, Ellas Tienen Nombre. They have a name. And so what they do is they're citizen data scientists who collect a bunch, sorry. They collect uh, like the locations, names, and a lot of information about different victims or these feminicide events that have happened across the city. So they have a database of these events where I then went in and helped create this interactive map in like JavaScript or whatever. And we have these events since 1985. But you can go to the website and kind of work and click on these different markers, the red dots, and you can, if we have an image of the victim, see the image, and then you see kind of like their story, what happened. But I don't know if you can see let me see if I can, is it annotate? Maybe not. I don't know if you can see. Oh, here we go. Maybe like the tabs up here, you can see some of the victims' like favorite songs, different things that you can kind of get more information about the victim, humanizing them, and trying to essentially as the name of the organization is Ellas Tienen Nombre, like give a name to the victim instead of just calling them a victim or things like that. Um, ah, okay, now I don't know how to delete this. Oh, here we go. Okay. Okay. So yeah, so working with um uh, okay. So working with this group and kind of doing this initial literature review and kind of getting a deeper dive into this domain, um, I wanted to figure out how to use my own skills, my own research background. And so putting all of this together, I came up with this question, how can I identify a narrative structure from a collection of topical images representing the anti-feminicide movement in Mexico, using computational methods, and particularly computational social science methods, which can be just computational methods in this case, I guess. Um, so what I'm doing is claiming that this movement's presence on Instagram is represented by a rhetorical narrative that has a relational structure, and it can be analyzed using local and global features. So in this case, I'm looking at local features as components within the image that can help represent narrative frames to be kind of their own subgroups within the network. And then global components or the global aspect of this narrative is just the full-on summary or the whole representation of what's going on. Um, to kind of break it down a bit, the local features in this case can be understood as subject, narrator, and action. And later on, I kind of create a concrete set of labels for each image. I'll kind of go through how that's done, but essentially, um, different labels are grouped based on the image and the meaning of these features. And so they can be grouped into these three different types of features. So for example, this is kind of like a call to action for a Women's March, the 8th of March, which is a big day in Mexico for this movement. And so it's an action feature. Here, these two images in the middle, they kind of help to construct a type of meaning for um, like this conceptual meaning. So here, this image, I don't know if you can see the illustration, but it's kind of like uh, very emotional. Um, and then kind of this selfie of this woman with a mask kind of staring at you it helps construct this type of like meaning or emotional implementation. And then here, down here, I don't know if you can actually read it, but it says 10 feminicides a day in Spanish. And so this kind of is more informational to an extent. And so I put that into a narrative feature. Um, and then at the global level, these images are kind of grouped into their own themes, and then we can use different models or different ways to understand how they're connected and what that whole summary is. So, just to take a step back and start off how I got the images, I started uh, off collecting before Meta took over Instagram, so it was fairly easy. I was able to get like geolocations and a bunch of things like that. And then once Meta took over, there was a lot of blocking and I was getting kicked off. And so just went in and created my uh, uh, customized content scraper, I guess, if you will. Um, collected a little over 19,000 images after cleaning and processing, ended up with about 16 and a half thousand images. Um, and ultimately, I was only able to pull the number of likes, the time of day the post was posted, and the original post comment. Um, and so, and then later on, I went in and annotated about 3,000 images just by myself to provide ground truth. I know just one human and the sole researcher annotation might not be the best ground truth, but it's kind of what I had and what I was able to find resources on. Um, so essentially, this is how I built the data set. The data, unfortunately, is not available online, but my process is, and that's just because um, Instagram policy and things like that. Okay, so after going in and doing kind of the qualitative review, qualitative literature review, excuse me, um, setting my research, setting my research question, claim hypotheses, things like that, I landed on three phases of analyses. And so first, I start off with clustering image feature embeddings, and then doing kind of like a human in the loop evaluation of different images from the different clusters that were brought up by the embeddings. And then I go in, so that's kind of like a nice way of um, getting an exploratory analysis of the data and getting really deep into what I have and what's online. And then I go into using multimodal large language models to label and generate different descriptions of the images just to see so that I don't have to go in and do, annotation and descriptions for all 16,000, but it also provides a way to see how maybe these models um, are reading an image if that I guess the wording makes sense. And then from there, I use the generated labels to build uh, the network structure and analyze the narrative in that regard, um, based on the semantics that were found. Okay, so uh, initially in the evaluation process for this cluster analysis, I pulled image embeddings from three different models. ResNet 50, which is kind of like a convolutional neural network image embedder. Um, I it's people say it's like the old traditional old whatever model. And then I used Clip, which is a vision transformer that kind of is really robust for identifying image embeddings. It's trained on image and text pairs. Uh, Blip 2 is also is another multimodal large language model. Sorry, not another, but it's a multimodal large language model. Um, and it goes through a multi-step process. And so what I did was I pulled just the image embedder from that model and used it to get the embeddings of the images. This one is interesting because it's just trained on images. It's not trained on image text pairs. Um, so then I went in and clustered these embeddings using a density, uh, HTTP scan, which is kind of like a density, um, reduces the density. And then I went in and visualized it, uh, and then evaluated the network with typical clustering metrics. Um, so, and then from there, I pulled the different clusters, pulled the top images from the different clusters and did kind of like a visual content analysis of a few images from each of the clusters. And so essentially throughout uh, overall clip kind of worked best. And I know some of the metrics didn't exactly excuse me, don't exactly show that. But if we look at kind of here is the visualization of the lower density embedding. So um, essentially what this does is it takes like these vector embeddings and it puts them into a two-dimensional um, format so that we can work with it and visualize it better. And so Um, Here, the comparison of the three models of getting those embeddings and clustering them. You can see here that uh, in the ResNet model provided large clusters with some noise and smaller clusters around it. Um, Same thing with CLIP, but there was a, I guess, like a stricter separation between two clusters. And then the blip2 was just overlapping clusters all over everywhere. Um, and so then I went in and looked at, okay, well, what, how big were each of those clusters? So you can't really tell. Um, and here you can see, okay, yeah, here are the two clip. Um, sorry, I don't know if I'm using my mouse. I'm not sure if you can see it. Um, but we can say here that like in the middle, the two blue bars are the two clip clusters that we found here in the middle. Um, and here, this you just see um, this large orange bar showing um, blip twos, just like multiple like baby clusters all around here on the right hand side. Um, and so this left, I guess, histogram shows how the average probability of each node within a cluster. So how likely is it that a node actually belongs to that cluster? And so here, actually, Blip had, 100% probability that an image belongs to a specific cluster. And you can kind of see that it ranges from 70% to 100% probability. So that's also really great. Clip and ResNet do the same as well, but there's still some stagnant, I guess, lesser probability from all three models. Anyway, um, this was really helpful for understanding kind of where the images were, which model kind of did best with different with the images that I used, and how are these images? So what does that mean, right? Like what are the clusters and why are they different or why are they overlapping? And so this is where I went in and got and looked at different images. Essentially, I there was a small part where I looked at with the objects, the icons, the background, and the different styles and frames within each image, and looked at, and so here's an example of kind of the images that I was working with. Um, and so in this case, I did that for the top, I believe the top five images for each cluster, um, because at the Blip2 came up with like 27 clusters, as opposed to 7 or 9 clusters from the other two models. So essentially, I went in and did like a um, content analysis of all of these images to see kind of to comb through and see what images were being placed into different clusters. And that's where I started getting an idea of what labels to start using, what are the kind of common themes that came up throughout the clusters and came up within the images. Yeah, so that's kind of this is the the main topics found qualitatively within the content analysis were comparing men and women's experiences, um, accusing, um, I guess, aggressors, people's life stories, life examples, um, comments of domestic and gender violence. There's a lot of protest imaging and, I guess, information. But there's also a lot of solidarity for victims or causes. And then from this method, um, I went in and decided on some specific labels. What I did add and what wasn't really very apparent in the images was um, seeing if kind of the model later on can identify if an image was created by a bot. Um, Not too much came from that, but I thought it would be very interesting if that was like a huge um, like classification example for this work. So um, I went in and kind of did uh, so the next step is me going, taking the images, putting them through different multimodal large language models to generate labels and captions. Um, I also, this is where I started annotating the around 3,000 images. For this, I used Label Studio. It's like an online so platform software, I guess. And so the annotated, the bar chart, yeah, on the right, my right. I think you're right. You're left. Anyway, the figure here, um, showed that the data is imbalanced, which was almost understandable with this label, but I wanted to provide a kind of general and specific review of um, different labels to see how the models could also classify things. Um, and of course, real world data is typically imbalanced. But regardless, this is kind of an idea of the random images that were annotated, um, how they're represented by labels. So using these labels and putting it through a multimodal large language model, I was able to um, generate image labels and oh, excuse me, labels and descriptions. And I again compared different models in this phase. Um, and the model that came out, I guess, best performance overall, specifically for this data set, was Llama 4 Scout. But essentially, I guess to take a step back, this is how large language models work. You put in your data. It can be any type of data, and then it goes through two different encoders, either an image encoder and a text encoder, an audio encoder and an text encoder, what have you, whatever is the multimodal aspect of it, and then it goes through this kind of process of of um, attention network output, and then things that are being generated. Um, and so, what was interesting is I put this model to go in and identify a top label and a second top label, and then provide a description. And so, when it did, um, it was able to again identify a digital image with text in Spanish as the most, which was the top label, the imbalance, where the imbalance label came from. And informational label was the second most, I guess, classified label by the model, which is really interesting because that means potentially that the text um, within the digital image was informational in that case, right? Um, there was a higher precision for illustration or cartoon. Um, there was the model again was sensitive to a digital image with text in Spanish and informational, potentially because of the label numbers and sizes. Um, and the F1 score, which is a combo of precision and recall, showed that a small group of people or an illustration or a cartoon was kind of um, provided most, I guess, the better understanding of semantic meaning in that regard. Also, uh, the model created its own labels, and for uh, so essentially, sometimes it did provide some hallucinations and things like that. But it was interesting because it was a little more specific. It said, well, this text in this image is in Spanish or English, but it's in Italian or it's in Portuguese, and so created its own label for that. And then for the second top label, it kind of said, well, none of these work, but I think more specifically, you need to do something about feminism, feminist protest, or feminist or protest. And so it kind of this potentially wasn't a hallucination, but it kind of tried to correct my own labeling, which was really interesting. Um, so so that was like the initial like evaluation metrics of the outputs. And then I put it through, then I used the generated descriptions and the annotated labels here, these are the different models that I used. And so these all were uh, kind of seeing how semantically similar was my ground truth data to the generated descriptions of the model. And so here it's just showing how, again, Llama 4 Scout model um, had the best output based on the different evaluation metrics. And so essentially, in that regard, the kind of, yeah, I guess this might be better. Um, uh, this kind of shows how the model was able to potentially identify some nuances. So label one kind of did just say, okay, yep, we did identify digital image with text in Spanish with, and that's exactly what it was. But if we go to label two, this is kind of where the nuance came out with how the model was able to review the image. Um, and it said, well, yeah, maybe digital image with text in Spanish is the first label, but it's also more informational, a more informational type of image. Um, or maybe here maybe it's more of like a protest text image, or maybe the signs or banners do represent protest in this regard, and they're not really connected in that sense. So um, looking at how the model was able to potentially understand nuance within these two labels was really interesting, and it provided kind of this like uh, uh, I guess not multifaceted, but just it kind of provided a little more context to how we can kind of see the narrative not just from like a one label or one perspective output, but it could be kind of nuanced in that regard. This is an example of how the model provided um, information for the image. So here we have solidarity, protest as the first and second, and then the generated description. I know I'm running out of time. I just saw that. I'm so sorry. Um, so this is actually um, so here I just was really quickly here. This is an illustration or cartoon, but the model actually looked at it as solidarity and protest, potentially because of the hand um, and the hashtag here. And so uh, this was really interesting to go through and see a large, like go through and kind of review how the model looked at different images. So finally, we're looking at the narrative structure and evaluating it in that regard. Um, so what I did was I started off by I created three networks or three graphs. Um, One just on the label embeddings, another on the label embeddings plus the generated descriptions, and then a third on the label embeddings, the generated descriptions, and then the original comments that the poster of the image posted, the account of the image posted. And so I went in and did some degree centrality and modality measures for the label graph, and then I went in and looked at global components using different embeddings and graph setups. So essentially, initially, the labeled graph was again very dense, overlapping, but the betweenness centrality here was really interesting because it did highlight it helped highlight specific nodes that could pose as semantic bridges between the different groups of the graph. And I know we can see here that uh, there is a large range. It's like there's no connection between us, and then every node is connected here. Um, but there are some kind of like, I guess, nuggets, if you will, that do help kind of transition bridge this kind of messaging throughout the different groups, which was really interesting. Um, and then I used the lead-in modularity, the lead-in algorithm to partition the graph, and it kind of did provide a fairly interesting separation within there to look at the groups. And although the score is not great, it helped kind of understand that it helped kind of show that maybe there isn't crazy overlapping in just two competing groups, that there are ways to kind of go through and see these partitionings for different reasons. So again, here are the local components or the local features that I used to um, to label and look at the combinations at the local level. And what I found, uh, I guess I'll come here. I guess, sorry, that slide is not there anymore. But what I found was that um, there was a lot of connections across different features. And of course, mainly because, uh, ah, sorry, I usually like to have like a little, anyway, um, the label digital image with text in Spanish was the top label, right? And so, of course, this narrator feature was going to be kind of very common throughout. And so, what I found was it wasn't just the narrator feature by itself because these labels were connecting to other labels within this group, but the narrator feature was actually having links to different features. So it was always a coupling of the narrator and the subject, or the narrator and the action, because one of these labels, informational, personal belongings or objects, digital image with text in Spanish or in English, these were being connected to labels from the other features. And so um, what was interesting here is that you found that although there was a narr kind of like a narrator voice throughout the network, it was supported by a subject, or it was supported by a specific action that was going on, which is really interesting and helpful because it just, anecdotally or off the top of your head, that kind of shows that, okay, it's not just someone yelling into the void. There is some supporting subject or some supporting meaning for this narration. There is some supported um, action or context for this voice. And so that was really interesting going through. Um, so so then looking at the global level, I implemented a uh, graph attention network where I threw I wanted to kind of use the ground truth data again to kind of have some type of supporting uh, I guess benchmarking. And so I put it through this attention network to have it to see how well it did the model classified excuse me, to see how well the network was able to um, I guess, uh, go into its different subgraphs based on the ground truth data. And I did it using using embeddings created by this variational autoencoder. Um, this figure here shows um, the semantic cluster embeddings and its flow throughout the network, and it kind of shows like the backbone of the network. So it's not like every node. It's kind of just like how it flows, and you can see the ups and downs and potentially where things were transitioning from the semantics. Um, and so here at this global level, I was able to use um, uh, these models to kind of get a better understanding of potentially how and where um, the transitions were happening. And if you look at the network here, there's a lot of um, like clusterings happening. Um, and they do have their different groups, but they're all potentially interconnected. And so um, what what I did find overall is that although this was a highly dense um, and kind of potentially overlapping network, the nuance and the small kind of contextual support from the different semantics found in the image or in the comments were very helpful to understanding what's going on with the narrative. Um, uh, and that the data was potentially imbalanced. Well, it wasn't potential. Um, and just again, I have to kind of thank the resources that were provided to me for this work. And yeah, thank you all.
Thank you. Thanks so much, Laura. Yeah, we have about like, oh,
Sorry.
my voice is coming back to me. Is it still going? No. Okay. We have like almost like 10 minutes for questions. So folks in the chat, you can either like put your questions down there or raise hands and we can go in like order. Um I'll be looking at the chat. But yeah. Oh, okay. We have a question already. Yeah, please go ahead, Tool.
Ah, hi, excellent talk. I guess this is maybe a question for like future work almost, but I guess I was also curious the extent to which um you get patterns like of aesthetics in the different images that you share, right? Because if you think
Mhm.
about like centralized political movements, like maybe Obama's political campaign, like there's a very distinct and like visual style with like a lot of the things that are produced. And then if you have a broader like protest movement, right? Like there's
Right,
like the people are putting a lot of effort into making these things look really nice, right?
right.
But there's
Yeah.
like very different styles. And do you think you would see like the styles more talk when the styles are aligned or like be shared in that way? Or would you see there be sort of like this like, you know, sort of like a hub spoke or more distributed things? Yeah.
Yeah, I actually I think that is interesting because the styles initially they were. So this movement works a lot or uses a lot of purple and green. Um and so surprisingly purple and green weren't like its own cluster, but they were kind of like within different clusters, but I mean they were still very dominant. Um, I did a workshop where I used some of these images as kind of support for creating synthetic data, and the model created a lot of green and purple images because of the aesthetic or the content. Um, but I think that you're right. It is a great future work uh to do to like go in and actually go into that deep content or even a visual discourse analysis of these colors and how they are represented. Yeah.
Thank you.
Yeah.
Yeah, we can
Oh, go
definitely
ahead,
get
Rachel.
that
I don't know.
question
Yeah.
from, yeah.
Oh, sorry.
Yeah, sure. Sorry about that. I hope
No.
everyone can hear me okay. I'm trying out new headsets here. Um, yeah, thank you very much. This is really interesting. I love to see this fusion of like machine learning with like grounded theory. I work with a lot of engineers, so it's rough to like advocate always for it, but I love the research that comes out of it. It's great. Um, I had a question actually about your workflow. From like a tooling perspective, something I get asked a lot about is uh, obviously this process, this grounded coding process is very, labor intensive, right? You mentioned saying, I'm sorry, I only have one, annotator, and you're definitely not the only person I've heard, talk about wishing they had a whole bunch of annotators. Meanwhile, in like the
Yeah.
machine learning, like, community, it's like, oh, I had one person spot check 30% of my examples and that's my ground truth or whatever. It's like that's kind of a
Yeah. It's
crazy
not good.
difference in the
It's right.
right, crazy. So what if you could imagine, like I get asked a lot to help like assist researchers with like tooling, or like they always want to not necessarily use AI to like, or like machine learning tools or recommender systems, not to like replace them, but to help them or assist them in sort of a human in the loop way to do the initial
Yeah.
coding. So if there's any, like, can you
Mhm.
think of like something that you would have, that you were like, man, I wish this was easier. Like, what part was that for you, and in what way do you think that would be? What was the hardest part here if someone's setting out and doing something like what you just did that was like just onerous and it should be easier than this?
Yeah, yeah. I guess to that regard, like the data set, um, it, this data set I made from scratch just, um, uh, I found some, like protest data sets, but it was very specific to protests. And I found, like overall, like social movement data sets, but they were very specific to one social movement. And I feel like different social movements are different. Um, uh, I guess, yeah, annotating was difficult. I was going to try to find a way to just not annotate and like use and just do a lot of like unstructured stuff. Um, but at the end of the day, you do need to like benchmark. So at, like the last step, I benchmarked against like the Cora data set and the Flickr data set, which are very robust and very annotated, um, well annotated data sets. So I guess I like the the hardest part was actually getting access to different models and figuring out how to just find space and memory to process all these images. Um, but from the annotator's point, I think that just, yeah. I mean, I use the LLMs initially so that they could just annotate the image for me, but it wasn't kind of like it generated their own labels and it generated like different things some of it, some of when I went in and compared my annotations to the models, sometimes I was like, oh, that is actually a better decision. And then other times I was like, no, this is way off. So I sadly at this point I can't really think of much other than like having multiple people go in and annotate the images. Um, I've been a part of that process, and you do the whole inter-annotator agreement and things like that, which is really helpful and really and provides better quality data. But uh, um, I don't know. That's also just I think people are still trying to figure that out. Sorry, I don't have a better answer.
No, thank you. That's great. I've done some of this myself, and I've tried to assist some other teams doing this kind of research, and yeah, it's similar. Hopefully, one day there will be a something
Yeah,
that helps us with that
yeah,
initial process. Yeah,
yeah. It
great.
just there's so much data out there, but it's like just making it quality is like the hardest part, I guess. Um, so.
Yeah, I kind of had a like question similar to that.
Sure.
Like on the
Yeah.
yeah, on the end of like, oh yeah, how do we like actually go about like making the decisions about how to validate, evaluate all of the because like
Hmm.
you can yeah, like obviously if we have like bunch of people who have enough time and like resources and everything, and if we had money, yeah, we could like have multiple annotators and everything and then do like um inter-coder like agreement checks and everything.
Right.
But given how limited our like time and resources are, like I guess yeah, because I also like never really know like how to okay, like the more is the better, but like how do we actually like like make those decisions? Okay, I'm gonna actually take a I don't know random sample of 20%, 30%. Like how do you go about that, I guess?
Yeah. So I kind of went in and just did like a coding of like, okay, create a folder, ran, create a folder of like a random 3,000 images. And then I went in and put it into like Label Studio, which is this, I guess, platform to help you just like, here's the image and here are the labels you want, click on it. But then I also did this like, um, initially with like 100 or 150 images or so, like, uh, it is hard because you also think, well, you have all if you have all those resources and you do the inter annotator coding, you still there's still like a lot of biases that are introduced and what is the like what are the privacy concerns and so like that's why I didn't download any account handles or what so it just like just dealing with just like all this raw data is like me as like a first year PhD, I was like, it'll be easy. It's great. Oh my God, we can do it, And now, and so now after going through, you're like, oh my God, there's so many things to think about, right? I did like a is this image biased type of like review for a while there, and then like one person doing that is like not um doesn't help anything. So it's just this like it is this like give and take of like do you want to work with the data that you want to work with, or are you just going to go and find something that's already been kind of like processed and eased through and um yeah, like sadly, like I don't know, do you give just a bunch of undergraduates extra credit to annotate things or like that's kind of like the main my solution just like at this point just like okay, if you guys want extra credit, just here do this thing which is also probably not good. I don't know. So yeah.
All right. Do we have any other like quick questions? We're almost out of time. And if not, I'll just thank Laura again. And in the meantime, I also want to share our next seminar's flyer. I just put it on the chat.
Also, sure.
Yeah,
Okay.
thanks so much for joining us today, everybody, and Laura especially. It was a great talk. Yeah, see you later.
Great. Thank you so much for having me.
Yeah, thank you.
Thank you.
Thanks.
Bye.